Hello, my name is Ecem Melisa Çevik. I'm a freshman industrial engineering student in Bilkent University. In this video, I'm going to explain my Physics 101 lab project titled Energy Loss in Bouncing Balls and the Coefficient of Restitution. The goal of the experiment is to examine the rebound height of a ball changes depending on the surface it hits. Before describing this experiment, let's start with a basic theory. When a ball is dropped from a height, it has gravitational potential energy, which becomes kinetic energy as it falls. After the collision with the ground, the ball does not return to its original height because some of its energy is lost to sound, heat, and deformation. To measure how elastic a collision is, we use the coefficient of restitution, E, which is defined as the square root of h1 divided by h0. A value close to 1 means the collision is very elastic, while a lower value means more energy is lost. For this experiment, I used a rubber ball, a meter stick, a smartphone camera, and 3 surfaces: metal, wood, and carpet. I dropped the same rubber ball from 100 centimeters onto these surfaces and recorded each drop with a meter stick visible in the frame, so I could measure the rebound heights. I repeated the procedure 5 times for each surface to increase reliability, and then I calculated the coefficient of restitution for every trial. The results clearly supported the theory. The metal surface had the highest coefficient of restitution, about 0.88, because hard surfaces return most of the energy back to the ball. The wooden surface showed a slightly lower value of around 0.86. and the carpet surface had the smallest value, about 0.76, since soft materials absorb more energy. All 3 surfaces also showed very small standard deviations, which means the repeated trials were consistent and the measurement method worked well. Even though the results were consistent, there are still several sources of error that can affect the measurements. The rebound height in the video can be difficult to read because the ball moves quickly, so identifying the exact highest frame is not always precise. The camera angle can cause slight parallax errors, and also the ball may not bounce the same way every time due to rotation or small changes in how it contacts the surface. These factors create small variations in the measurements, which is why the standard deviation is important for showing the level of uncertainty. In conclusion, the experiment demonstrated that the coefficient of restitution strongly depends on the surface material. Harder surfaces, like metal, allow more energy to be returned to the ball, while softer surfaces, like carpet, absorb more energy and result in lower rebound heights. The data matched the theoretical expectations, and despite small experimental uncertainties, the overall patterns were very clear.